Very good morning. Today we'll discuss about the charts for reference on the third day. The agenda today is to discuss on the box plot. So you can see there are three charts on the left hand side. You can see the histogram on the middle, which is the box plot. On the right hand side, you can see the histogram with the line chart. As we know that the chart gives more an easy understand about the data and the pattern of the data and how the data is distributed or a part to whole and give a more vivid, easy perception of the data than your normal two-dimensional data represented tables and columns. So, what kind of a data does the box plot? These are all graphical, predominantly that represent the frequency of the numerical data values. For any numerical values, then box plot would be your options. If you want to compare between two or more groups and you would like to know each of the groups of the mean, median, mode, then your obvious choice would be your box plot. We'll see in the next slide in the deeper mode. As I said, it's a numerical data. This falls under the category of descriptive analysis. You can see under descriptive analysis, we have numeric and categorical data. It's a purely numerical data. And what kind of numerical data? Either it may be a discrete or it may be continuous. That is to numerical data. That's it. For example, if there are 30 students who scored marks in the range of 4 packets 0 to 30, 30 to 50, and 50 to 80, 80 to 100. Not are all the students they score the same mark. Even they score the same mark, then how we can get to know about the students, the minimum mark of the students in a subject, and the students who scored more marks, and an average of the students in the class. No one can get a score marks more than 100. We'll discuss about it in the next slide. As I said, this is the exact box chart. This is 100% is splitted into 25, 25, 25, each into 425. And you can see the middle, the value, that is the median, Q2. Okay? Q2 is the middle value. And you can see the circumference, right? Then we'll go little more deeper. Okay. The 25 first 25% you can see Q0, which is the minimum value. Okay, and the first quartile Q1, that is 25%. And the third quartile you can see in the box of this value. And median is nothing but the middle value. And maximum would be 25. This intercalated ranges IQR. This is the difference between first and the third quartile. Normally, the box plots run from first quartile to third quartile. The line interesting, the marking the means. Okay, we'll go a little bit deeper. You can see this is a kind of chart. You can see this IQR, Q3 minus Q1, third quartile minus first quartile. And you can see there are outliers which is above the your viscous actually. This is a classical example of the test scores by the students represented in the dot chart. In the bottom, you can see the representation of a dot in a box chart. See, by seeing this, you can see the first quartile start here, right? We'll see. So that is Q1. Q1 start from here, 60, and this Q3. And you can see the median. This is the middle value. 75 is the median value. So when you're seeing this score, you can't interpret anything with this dot chart, but you can interpret the number of students. There are 12 students, they fall under the bucket. If you see, there are 3 students who scored 60 marks. You can able to find it, but you can't get the average. What is the class average of the 12 students average? You can't get it. But if you go with the box plot, you will get the middle value, the average, that is the median. And here it is easy for you to understand the minimum value, that is 30, and the maximum value is 80. Right? Here it is very easy to get the min, max, as well as and the median. There is one more thing, interesting thing is we'll get the mode. You can see the 70 is repeating 3 times and 60 is repeating 3 times. This is our mode actually. Okay, we'll see that. This is a typical example, a classical, well known example with monthly salary wise your career length. You can see this accesses start from 5,000 to till 30,000. This is directly relational with your salary wise career length. In terms of career length, here mention the number of years of experience here. The maximum number of experience, the career length, the higher the salary. The minimum years of experience or a career length shows the minimum salary ranges actually. In between the years, in the bucket of 21 plus year, not are all the salaries, they are the same average. You can see, right? The median is different. These are all the groups actually. And these groups are given a different colors. This is group 1, this is group 2, this is group 3, this is group 4. Likewise, even the experience are still categorized by the department. Not all the department, even though they are having 21 plus 1 years having experience, they won't get the same salary based on the skill set, based on this business, how they are operating, how they are generating the revenue and everything. And this is a semantic distribution, skewed distribution. You wonder about it, what is skewed, what is semantic. Typically, you know about it every year, you will get a pay hike based on your experience. They will go, they will give an increment in some percentage actually. The HRs, they will say that no, it won't come in the umbrella. It is under normalization. You heard about the word normalization. So it's a buzzword for everyone, normalization. Sorry, we are not unable to provide us somehow your scores is not coming to normalizations. It's not only you. They're taking entire employees and they put it in the bell curve. There are different curve actually. And the bell curve, you can, it is similar, triple, the bell curve would be a middle value would be this value. And this is the middle value. And they will separate this into right and the left actually, right and the left. And this, you can see that the skewed on the left actually. Okay. And by this is histogram, typical histogram. Here, this is a box plot. What is a very difficult, what is the comparison we can do it? When you go with the histogram, both are numeric representation. When you go with the histogram, you can't find the central, the median value, as well as the data, as well as the outlier, right? Predominant reports, predominant charts are get affected by the outliers. As part of a ETL, data cleansing, you need to remove these outliers. This is the outlier. This is outside of the whisker, your whisker. Actually. You can see the outliers. These are anomalies. This will create anomalies in your data, in your data chart. You need to delete them. Here you can able to find it actually. But normally you can see these. There is won't be any continuous here. But you can't find this out there. But with the box plot, you can easily identify the outliers as well. And see, this is a download, internet download by the users throughout the year of 2020 by month report. See, you can see the outliers here. See the viscous actually. So you can see this, the 2022 November, you can see the viscous is coming here. And this is the min, this is the max. You can see the pattern actually. Now we understand the about the box plot. Here, now you can see that you can see the normalization here. This is a bell curve, as I said, right? This is a mid value. It is nothing but a median. And you can see this, the box plot is represented the same chart here. Now we can find the confidence, 95 and 95% confidence interval. Here, this what we are getting as the mean value, standard deviation, the variances, the skewness, and the kurtosis, and the number of values. Here, the skewness is nothing but how the data is spread across from left to right. You can see this one, right? This data is spread like this. The kurtosis is nothing but the height, height of the curve. This is the characteristics. Okay, and you can see the minimum is 52. You can see this 52. The first quartile is 73. The median is 79. You can see 79 somewhere here. The third quartile is 90, and the maximum is 152. This is the max. This is how they are represented here actually. And this confidence intervals of mean, median, and standard rate they have given is this is statistical value. We'll go a deeper next session. So far we discussed about the box plot. Now, how the box plot is represented in visualization, right? We know that what is mean, median, what is whisker. You can see this is whisker. You can see, right? This T shape, right? This is whisker. You can see mean, man, median, upper quartile Q3 and Q4. And this is a normal distribution. You can see in the normal distribution, this is a normal distribution. This is positive skewness, right? This is negative skewness. So as long as if your data is skewed to the left, it's a positive skewed, and then if the data is skewed to the right, it is negative skewed. That's it. Now you can see these outliers, right? And you can see that how the data is represented here, how it is, what is the lower extreme, upper extreme, medium value, like that. Now we understand that in what we need to go with the box plot chart. I hope this is a nice session for you to understand about your box plot. Predominantly, it tells about the central tendency of your data, about that captures your mean, median, mode, and your outliers.